Year 5. I know you guys are studying space, which is like one of my all-time favorite topics. And I just so happened the other day to get these little erasers, these little rubbers that are made to look like the planets. And it gave me an idea. I just want to show you something cool. I think one of the most important things you can learn in school, also when thinking about space, is just the scale of the universe, the scale of things. And I'll show you why. So the word science literally means a way of knowing, a way to know something. And that's pretty cool because you can use your way of knowing to make decisions when you see things in the news. Should you be worried or not? So I printed this off. You see stuff like this all the time. It says, tiny asteroids, super close Earth flyby. Okay, well, how close was this asteroid? So you read through here, and I highlighted the part, and it says, it was an impressively close flyby. According to the European Space Agency, the asteroid passed 42,735 kilometers away. Okay, so what does that mean, right? You hear that number, 42,000 kilometers, and you think, is that a lot? Well, to scale. These numbers represent the diameter of the planets, okay? And we're going to use this to sort of come to a conclusion about that news article that I showed you. So Mercury down here is only 4,800 kilometers in diameter. She's pretty small. Venus, 12,000 kilometers in diameter. Our little home, the Earth, is only 12,700 kilometers. Mars is very tiny, 6,700. Here's Jupiter, right? The big one, 139,820 kilometers in diameter. We've got Saturn, Neptune, and Uranus are basically the same. I've rounded these, obviously. Obviously, it's not exactly 50,000. I think it's like 49,000 something or other. And of note, the Sun is 1.4 million kilometers in diameter. Okay, so here are the planets. Now, how is this going to help us understand the asteroid flyby that I just mentioned? Well, instead of just putting these here not to scale in their distance from the sun, I'm actually going to just model the distance from the Earth to the moon, okay? Now I'm going to use the Earth to show us the Earth, and I'm going to use Mercury to show us the moon, because my packet of erasers didn't come with a moon. But, so let's do that now on the table. Okay, here's our Earth. Like I said before, it's about 12,000 kilometers in diameter. I think it's upside down. Oh yeah, there's Australia. Anyways. This rubber is actually 2 centimeters, almost exactly. So I could divide this in half and find out really what is the length of 1 centimeter on this scale. So there you go. On this scale, so the scale of this little eraser here, sort of rubber, okay, 1 centimeter is about 6,300 kilometers. I'm rounding all these numbers to make them nice and easy. Now remember what I said before, we're going to actually model the distance from the Earth to the moon. So we got to figure out how far away is the moon. Hey Siri, how far away is the moon in kilometers?
Just a sec. The distance from Earth to the moon at 10:21 Australian Eastern Standard Time, Tuesday, the 26th of May 2020,
very accurate,
is about 386,842 kilometers.
Wow, did you hear that? Okay. That's how many kilometers away the moon is from the Earth. And here is our scale, right? Okay, then I need to divide that number by 6,300 up here, and that will tell me how many centimeters away I need to place my moon. Okay, let's do that. Hey Siri, what's 380,000 divided by 6,300?
380,000 divided by 6,300 is about 60.3174.
Thanks, Siri. Okay, that's about 60 centimeters I need to place the moon away from the Earth. All right, well, there's my Earth and halfway point, and boop, there's the moon. So, oh yeah, the moon is only 3,400 kilometers in radius, diameter, so. Okay, not too bad. Now, how is this going to help us determine our asteroid? Well, I know an interesting fact. And the interesting fact that I happen to know is that you could fit every single planet in the solar system between the Earth and the moon. Now, you might be thinking, well, yeah, Mr. Black, these are pretty small. Of course they fit between the Earth and the moon here. But remember, these aren't made to scale. Okay, Jupiter, I think we said was like 137,000 kilometers in radius. So I'm going to draw these to scale, and we're going to see if we can fit them between the Earth and the Moon. Let's have a look. Okay, so really the final step here is I got to figure out how many centimeters each of these planets should take up, because they're not made to scale. Actually, some of them might be smaller. So anyways, let's find out. How do I do this? Well, I've got the diameter here of the planet. I've just rounded it. It's 4,800, but I've just divided it down. And so I need to divide this by my scale. And I said that the scale was, here it is, 1 centimeter equals 6,300 kilometers. Okay. Well, if this is 4,800 kilometers, it's going to be actually less than a centimeter. So I need to divide all of these numbers here, okay, by 6.3. So we've got Mercury down here at the bottom, right? Less than a centimeter, 0.76. Okay, Venus is up next, and Venus is almost the exact same size as Earth, so you can see 1.9 centimeters, where Earth is 2 centimeters, so that's what we should expect. Okay, Mars is about half as small as the Earth, so we should expect 1 centimeter, and that's what we got, 1.06. Jupiter, the big one, right? 139,000 kilometers divided by 6.3, about 22 centimeters on our scale. Then we've got Saturn and Uranus and Neptune is about the same. So the question is, on my scale here, I've told you that they'll all fit. Can I actually do it? Well, let's find out. Ah, look at that. We did it. We actually fit them in. I measured them using the ruler. Okay, I'll show you. So as you can see, Venus here is like less. I could barely fit Venus in, but they made that pretty close to scale, which was nice. I actually think maybe they made the rocky planets to scale because they fit nicely here. So Venus was perfect. Mars was almost to scale. But of course, we get a problem when we get to Jupiter. So Jupiter, I think we set up here was 22 centimeters. All right, so I put my ruler up. Oops, see, almost at, wait a second, just about at 22 centimeters. So hang on, can't do this while I'm looking at the camera. Okay, so Jupiter. Then the next biggest was Saturn, and Saturn fit there. Okay, and then Neptune and Uranus. I mean, look at this. Look how close I was. All right. But when we step back and look at the big picture, that's pretty incredible. You can imagine how big, just how big Jupiter and Saturn really are. It's amazing. They all fit between the moon. Every single planet will fit between the Earth and the moon. There's a lot of space out there. So let's go back to the beginning. What is that? Knowing that all the planets can fit between there, what does that tell us about this asteroid flyby article? Well, I think we said that the distance was 42,000 kilometers. So let's mark that on our chart, 42,000 kilometers. Where would that be? Asteroid would be about, at our scale, 6.66 centimeters from Earth. So let's find out where that is. I'm going to take my ruler here. 6.6 centimeters would be right there. Okay, there is our asteroid. I think about 42,000 kilometers. I can't really conceptualize that in my head, but what I can think about is that means that the asteroid was farther away from us than all of the planet of Mercury, plus all of the distance of the planet of Mars. I can't even hold these so you guys can see them, right? Plus all of the distance of the planet of Venus, right? So like if you think about if I told you the asteroid came 42,000 kilometers away, you'd think, oh, that's probably pretty close. But if I said, actually the asteroid was further away than the distance of the next 3 rocky planets combined, you go, oh, that's not that bad actually. So anyways, science is really fun, and it can help us understand things, and also it's just really cool to make a model and see that it all sort of works out. Okay, bye.